Hello, ladies and gentlemen. Welcome back to Math 10C, Chapter 5, Section 3, Interpreting and Sketching Graphs, Part 2. Now, in the last part, and I'm splitting this up into two parts because it's getting kind of long, and I want to be nice to you guys, but don't tell anybody. Oh, you shazbot stop that. In the last part, we talked about values. We did graphing and reading information off the graphs. Now, one thing that people have trouble with is turning this part G here. Model this function using function notation f. Well, what you do there is you look at the equation y equals mx plus b. Now, as I said, this is chapter 6, but if we learn it now, it makes this section a whole lot easier. Y equals mx plus b is the equation for the straight line, where b is your y-intercept and your slope m. Now, slope is rise over run. How high you go over how far you go. Now, if you can remember that, it makes the rest of this lesson so much easier. Come on, you shazbot. Now, here's another question we're going to work on. Now, a tank had some water in it. The water began to leak out at the rate of 60 liters every 6 minutes. The graph to the right describes the situation. And notice once again, I have a nice title. My axes are labeled with numbers and units, so I know what we're talking about. So how much water was in the tank to begin with? What was my beginning value? At 0 minutes, 200 liters. Now eventually I'm going to point out that's my B value, or my y-intercept. Now, next question, how much water is in the tank after 15 minutes? Well, I'm supposed to get out a ruler, but you'll notice in this example, I'm right on the line. So at 15 minutes, I have exactly halfway between 40 and 60, which is 50 liters. Now, the next question, when was there 150 liters in the tank? Well, 150 liters is exactly halfway between 140 and 150. Oh. Ooh, 5 minutes. Tank. Okay. Now, is this graph continuous or discrete? What's continuous? When was the tank empty? When was volume 0? 20 minutes. So this is reading information off the graph. This you should be able to do. The hard part, model this graph using a function g. So do that. Y equals mx plus b. Y-intercept, slope. So what's my y-intercept? Now I've got to make this a little smaller so I can see the graph and the question. B is 200. Where did I start with? 200. Now, what's my slope? Excuse me. Sneeze into your armpit. So, what is slope? Slope is rise over run. So, looking at my graph, choose 2 points. Far apart are best. Here we go, 200. I'm going to change color again. 200. There we go. 2 points nice and far apart. In theory, I can use 2 points close together, but it's possible to screw up. Much better to go far apart. So what is my rise there? I start at 200 and I go to 0. Now note here, final is 0. My initial is 200. So that's minus 200 is my rise. Now my run, I start at 0 and go to 20. So that's 20 minus 0, or minus 200 divided by 20. Now, grab Mr. Graphing Calculator. What is minus 200 divided by 20? Minus 200. Oh, no, you shazbot. Graph. Clear, sorry. Minus 200 divided by 20 is minus 10. So my slope is minus 10 x. So if, Oh, you shuzzbot. Stop that. People are watching. Okay. So instead of writing y equals, function notation, g of x is minus 10x plus 200. Remember, makes it much easier. G of 10, volume of water in tank at time 10 minutes. So G of 10. Now this I can actually read off the graph. G of 10 is 100. But the reason I did this equation is so I can have Mr. Graphing Calculator do the work and check my work for me. So grab your graphing calculator. Let's graph this. Y1 equals minus 10x plus 200. Y equals, clear, minus 10x plus, brain fart, sorry, wrong, plus 200. Sorry, 150 there, I'm getting old. Enter. Now, your windows are supposed to be minus 10 to 10 at the beginning. But what do we know about this graph here? Well, we start at 200 for y, so y should be 0 to 200 and x should be 0 to 20. So window 0 to 20 for x, 0 to 200 for y. Now, usually the biggest problem here is you mix up your maximum minimum. If you tell the computer to go x minimum 20 and x maximum 0, it will go, what the fudge pot are you talking about? Because it's dumber than a second coat of paint. You have to be very specific with it because it is dumber than a second coat of paint. Just fast. Now, there's my graph. Now, once again, why did I ask you to graph it? Well, because I'm evil and I smell funny. But we can also go G of 10. When x is 10, come on, sorry. When x is 10, go to table of values, second graph table. X is 10, y is 100. Yes, we already figured that out. But here's Mr. Graphing Calculator doing the work for us. If I didn't have the graph in front of you, this is what you'd have to do. Now, solve g of x is 150 and explain. Okay, so 100g, oh, you shuzzbot. That is minus 10x plus 200. So we have to solve this equation for x. Now, how do you solve the equation? 150 equals minus 10x plus 200. So the easiest thing to do, remember BEDMAS, brackets, exponents, multiplication, division, addition, subtraction. You do brackets first, addition, subtraction last. Working backwards, you do addition, subtraction first. So 150 minus 200 is minus 50 equals minus 10x. Then you do addition, then you do multiplication, division. Now double check my math for me because I'm getting old and making too many dumb mistakes. Okay. Now, how do you get rid of times minus 10? Yes, you divide both sides by minus 10. So grab Mr. Graphing Calculator. What is minus 50 divided by minus 10? So I got 5. So at 5 minutes, there is 150 liters of water in the tank. Notice how it's much easier to say g of 5 is 150 rather than write out the sentence. That's why we use function notation. Now, double checking this, we want to scroll up till we find y is 150. There we go, x is 5. So if we didn't have the graph, we could just look at our table of values. That's what I'm trying to stress here. Okay. Now you don't absolutely have to graph this because I've given you the graph, but if you can come up with the equation, Mr. Calculator will do the work. Okay. Now, slight change of pace. I want you guys to do this graph. Sketch a graph to represent the situation. You put the plug in the bath and turn on the taps. You leave the bathroom and return to discover the bath is overflowed. You turn off the taps and pull out the plug to let out some water. You put the plug back in. I need you to draw this graph. So, okay? What I want you to do is do that, and then we're going to do part E together. Compare your graph with that of another group. Now, there's no other group, just you and me. So, I'm going to pause the recording. I want you to draw your graph and then compare it to mine, okay? So, pause the recording. Get it done. Come back. Okay, now, my graph, part A, you put, oh, you should about stop that. You put the plug in the bath and turn on the taps. So what's going to happen? It's going to go up like this. Now, here, I don't know the time. I don't know how fast the tub fills up. I don't know how much water we're putting in. I don't know how big the tub is. I'm just putting in. So this is going to be a steep increase. Okay? Then what happens? Turn and discover the bathtub is overflowed. Now, when it's overflowed, what's happening? It's leaking on the floor, or there's a constant amount of water in the tub. I'm going, oh crap, oh crap, oh crap, oh crap, oh crap. You turn off the tap and pull out the plug to let in some water. Let out some water, so what's going to happen? Water's going to flow out. This is C, B, A. Now, what happens in part D? You put the plug back in. The water remains constant. Notice you've turned off the taps, so you're going to have a constant amount of water in there. Now, comparing your graph to my graph, how are they the same? Same. Well, same? Well, it should be same basic shape. Same basic shape. It goes up, it stops, it comes down. Something like that. Now, how are they different? Different numbers. Notice mine stopped at like 9 minutes. I noticed it was overflowing at 36 centimeters of water. Did you have 9 and 36? Probably not. Something like that. 8, 10, 4. As I said, this all depends on the tub. And no, you're not doing this as homework trying to get the tub to overflow. Okay? Just going, is your graph basically the same shape? Yes. Steep, flat, sorry, steep up, flat, moderate, steep down, and flat again. That's what I'm looking for. Numbers are exactly the same? No. That's reality. Okay? So that's it for me. Now I want you to go do the 5.3, check your understanding, and we'll talk about that in class, okay? Good luck.